Hey, this is dumediat. I'm here on BremSter's channel once again to bring you another puzzle. This one is called 10 Lines 2 Region 10 Lines by Isamook. And this puzzle has a couple different rule sets we'll walk through, but first and foremost, we've got normal Sudoku rules. So each row, each column, and each 3x3 box will contain the digits 1 to 9 once each with no repeats. These gray lines are called 10 lines, and these lines are made up of different numbers of segments, each of which sums to 10, and these segments don't overlap. So if we were to look at, for example, this 4-cell line down here, this could be one segment that sums to 10, and like 1, 2, 3, 4, that would work. Or we could divide this into, I'll use green here, 2 different segments here, with that sort of being the dividing part. And so this segment here would sum to 10, and this segment would sum to 10. But what we can't do is have, for example, this segment sum to 10 and then sort of have an overlap on this cell. That's not allowed by these rules. And on a 10 line, digits are allowed to repeat if allowed by other rules. So there's no restriction on repeat digits along a gray line. And I'm meant to assume that this line is different than this line. It's not a branching line. These are just 2 different lines that intersect. And we also have region line, sum lines. And so these blue lines are divided up by the box borders. So for example, we've got this border here, which divides this line, and this border here. And so this line will contain digits that have the same sum within each segment. So if we look at this line, this one will have the same sum. This cell will have the same sum as these 3 cells, which then has the same sum as this cell. And these digits don't, these lines don't, I'm assuming don't run parallel, like there's no hidden blue line coming up this way. Okay, those are the rules of the puzzle. I'll go ahead and restart my timer now, and let's give this a try. So I noticed a couple things. So when I was looking at this and explaining the rule for it, I noticed this digit, whatever it is the same sum as these 3 cells. Now those 3 cells all see one another, and so the minimum I can make these is 1, 2, and 3. So then the minimum I can make this is 6. Of course, the maximum is 9 because that's the highest digit we have in this puzzle. But also this is the same sum. So this is also 6, 7, 8, 9, and is the same digit as this one. Mark that in red. We've also got this sum line, which again, this is 3 cells that all see one another. Minimum is 6, so this is also going to be 6, 7, 8, 9. Same with this one. The same thing as up here, and this cell here is the same as this sum, but so is this cell. So these 2 are the same, but this sees red. So this can't be the same digit as this one, so we can make this a different color. Now let's go ahead and make it orange. I like going in rainbow order when I make these, when I color. And so these are also going to be 6, 7, 8, 9. We've also got something interesting here is this is the same as this is the same as this. So these 3 are the same digit, just repeated along the line. We know it's not orange because of this cell, but I don't think we can say whether or not it's not red, because none of these cells see a red cell so far, so we can't really color this yet. Plus it's any digit because it's just 1 cell sum, so these could even be 3 ones. It's fine. Okay, there is something interesting though about this 5-cell line. So we can't have, well, we could have in theory this just be 1 5-cell 10 sum. I wonder if that would work. For that to work, this would have to be, if these were 2 7s, that would be, no, that's not going to work, obviously. It could work because digits could repeat, but in this case it can't because these would be already 12 minimum. So we can't just have one segment along this line. So there's going to be at least one division point. None of these can be a 4-cell segment. One reason is because this would have to be 10, but also because we would need 1, 2, 3, 4, or I guess these could repeat, but this would still be 1, 2 plus 1, 6, but none of these can be low enough. And we can't have, we know, for example, that this has to join up with this along the line, because if not, it's a 1 cell that contains a 10. And same with this. This can't be a 10 either, so this is going to have to join up with exactly one of these two arms. So we're going to either have a division point here, or we're going to have a division point here. But they're the same cell, the same number. So if we were to make this 9, for example, that's not going to work, because one of these has to be a 3-cell sum. So the maximum digit you can place in a 3-cell sum to 10 would be 8. And the only way it's going to be 8 is if these are both 1s, for example. You can have 8, 1, 1 and have it sum to 10. And then this would be 8, 2. I think that's still possible. Something else I noticed is we've got 5 cells in a row that sum to these two numbers, plus we've got this cell we have to account for. So we've got, I'll just call it this region sum line sums these 3 cells. And this region sum line here sums these 3. So this is a minimum of 15, plus if we make this a 1, that's a minimum of 16. So that means that these two digits have to sum to at least 16. And so because of that, they can't include a 6, because the other would have to be at least 10. And similarly, this can't be a 7, because this would be an 8, that only gets us to 15. So this is 8 or 9. This is 7. This is 9. This is not 6 either, because these are the same. So I see we've got some restrictions on what these cells can be. Okay, so what are our options? If this is a 3-cell sum, this could be 7 with a 1, 2 pair to get us to 10, or it could be 8 with 2 1s. Regardless, there's a 1 if this is the 3-cell line. And if that's the case, if this is 7, this is 7, and this would be a 3. If this is 8, 1, 1, this is 8, this would be a 2. Okay, and then if it's the other way, so this is always 1, 2. If we flip this and make this the 3-cell line, this could be 1 or 2. This could be a 3. Okay, so they're pretty low digits on here. We also know because of this is either a 7 or an 8, this always needs a 1, because if you don't use a 1, the smallest total you can get is 2 plus 3 plus 4, which is 9. This doesn't need a 1 on it, because this could be, or does it? If we don't use a 1, this would be 2, 3, 4. Let's write that in. And this would be a 9. So this would need to be a 1. But then what's this? cell. Oh, it could be a 5. And then, so this would be a 2, and this works because this would be an 8. Right. And this could be 8, 1, 1, and then 8, 2, and that works. Okay, I think it works. I don't see any reason why it doesn't. Okay, I thought I saw something there, but I caught myself. Okay, so we said that this has a minimum sum of 16, but it also has a maximum sum of 17. So we've only got 1 degree of freedom here. So for example, let's say this is minimum 15, 1 plus 2 plus 3 plus 4 plus 5. These two cells can be an 8 and a 9, summing to 17. So this can be a maximum of 2. If we try to make this a 3, we get a total of 18 in these, minimum 18 in these cells. And this would have to be 2 9s, and that can't be. So this is also a 1 or a 2. And then this is either, this is sums to 3, this is either 4 or 5. Is there any problem if this does have a 1? Okay, well, one thing I do see here is that this can't be a 6 sum because it would be 1 plus 2 plus 3, and then this cell would have no valid digit in it. So this is at least 7. Okay, that is something though, because to make 3 cells sum to maximum 9, you need at least 2 digits from 1, 2, 3. And you can prove that to yourself pretty easily. If you use 2 digits that are above 1, 2, 3, you're already getting 4 plus 5, and that already sums to 9. So you need 1, 4, 5 would be the minimum for that, and that would be 10. So we need 2 more digits from 1, 2, and 3 on this line, and we have our third one here. So none of these cells on this 10 line can be 1, 2, or 3. So these are at least 4. And I'm just going to write this in for a minute. I'm going to delete it in a second because what I was thinking is the possibilities to divide up this 10 line are either to use a 4 cell line, which won't work now because the minimum for just these 3 is already 15. And so we're going to have segments here, 2 different segments. We can't use 3 segments, 3 cells along a segment because the other one would be 10. So we have, I'm going to use a different color to note this just because it's going to overlap. We've got that segment and this segment, which each sum to 10. Now the only way to make this work is if this is 4, 6. So that's a 4, 6 pair. And then this can't be 4 or 6. It can't be 5 because then we need another 5 here. So this is 7, 8, or 9. And this is 1, 2, or 3. So it's 1, 2 pair looks down, making this 3 and this 7. Very nice. And that's going to give us this 8. Okay. And then this can't be 8. Oh, okay. Let me get rid of this coloring for a second here. There's a few things I'm seeing now, but let me do the one I saw first. If this is 7, this needs to be 1, 2, 4, but we used the 4 up already. So these have to be 9. Very nice. And then 9 in this box is restricted because it can't go back on its own line. because it would be summed to more than 9. So a 9 looks in by Sudoku. So the 9 in this box goes here. So it places in one of those two cells. Okay, and then the ways to make 9, we can't use 1, 2, 6. It can be 1, 3, 5. Oops, I thought I had pencil mark checker off. Let me just turn that off. It could be can't be 1, 2, 6, can be 1, 3, 5, and it can't be 2, 3, 4. So this has to be 1, 3, 5, making this a 2. And that gives us our division along this 10 line. Because we now have 8, 2, that already sums to 10. So then this one has to sum to 10 this way. And now the only way to do that is the way I mentioned before, that kind of the out that I had was to make this 8, 1, 1 with a repeat digit. That's a 2. And now the logic I was looking at before actually works. This can't have a 1 on it for 2 reasons. So this is a 2, 3, 4, and this is a 9. This 2, 3, 4 looks over, makes out 5. And we've got a sum to 8 here, so everything seems to be working. And we can prove this to ourselves before. We've got 1 through 5, which sums to 15. That's 17, and these two sum to 17, so all that's working. This 1 looks down, making this 5. We've got a 1, 3 pair here. Okay, it was a lot of activity we got. About this line. I think this can still be 1, 2, 3, 4. This cell would have to be the 4 because this sees 1, 2, and 3 already. In fact, what are these 3 digits? 4, 6, and 8. And by Sudoku, there's a 5 down here. And there's a 2 here by Sudoku. Okay, this cell can't be an 8. And the reason for that is this cell sums to these 2. So if we were to make this an 8, this would have to be a 1 to sum to 9. And this would be a 9, but that puts 2 9s in row 7. So that's not an 8. But I think, okay, so the maximum for this cell is actually 7. And the minimum is 5 because this is a minimum of 4. So this is 5, 6, or 7. And so this has a maximum of 2, actually. It can't be 3. Okay. And so this sums to 5, 6, or 7. Can't have 1 and 3 on it, though. So this actually can't be 5. Because it would either need to be 2, 3, or 1, 4, and both of those options are ruled out. So this is actually 6 or a 7. And so this will need a 2 on it, because if we don't, it has a minimum of 4 plus 5, because the 1, 3 are gone. So that has a 2 with a 4 or a 5 on it. So this is either 1, 6, 7 or 2, 4, 6. Okay, I see 2 by Sudoku is up here. I don't know if it's time to look at these yet. It is a little restricted. So if I just type in all these possibilities, this row has 1, 2, 3, and 7 taken out. So we can take that out of all of these. We also have a 9 looking at this cell, so that can't be 9. Yeah, this is true too. It can't be 6. The reason for that is a little complicated, but if this is 6, this is a 2, 4 pair. But if this is not 6, if this is 7, this is a 1-6 pair. So one of these two is always 6. And so this cell sees both of those. So if we were to put a 6 here, this would be 7, 4, and then we'd have to have a 3 here, but we can't. So these are not 6 either. Not sure we need that step, but it's there, so I'll take it. Noticing here 9 by Sudoku has to be in this cell, which then puts it down here. Oh, and actually, yeah, this can't be a 9. This is a 9. We could have 1 9, but then this would have to be 10. So that's the 9. And then 9 by Sudoku has to go here. Get a 9 up here. And then, yep, so that matches up with our last 2 9s we need. I think this can still be a 9 with this being a 1. In fact, it has to go over here. What is this triple? 6, 7, 8. Eight by Sudoku. I don't want to pencil mark that. How is this one? This one has to be 3 cells that sum to 10. So there's not going to be any division on that cell. It's just 10. But there's a lot of ways to do that. You can at least say there's no 8 on the line. But, I mean, because the maximum you can have in 3 cells summing to 10, where they all see each other, is 1, 2, 7. But we don't know enough about box 9 yet to, I don't think, make any deductions there. So this is a minimum of 5. Maybe it's this line we need to think about. 5, 6, 7, 9, because it can't be 8. This can't be a 5 because it would need to have, it couldn't be 2 cells. It would just be double 5. So it would need to be 3 cells, but then that would be a minimum of 11 already. So that's not a 5. So in fact, we know that this is a 2-cell segment. Make this one orange. So this is 1, 3, or 4 to get this sum. This, okay, so that helps here. This can't be a 3-cell segment summing to 10 because this would make this by itself. So the other way to come to that conclusion is we need to draw this line because this can't be by itself. And so this also couldn't be a 3-cell segment because then this one would be on its own because it can't join up with this top one. So we've got 3 segments here. So this 6, 7, 8 makes this 2, 3, or 4, which annoyingly works. And this 2-cell can't be 1, 9, or 2, 8, or 4, 6, because if it was 4, 6, it would take this out. That's cool. So this is a 3, 7 pair. Don't think we know anything about 3 and 7 to roll one of these out, but we do know this is 1, 4, 6, and 8. This can't be, this can't be 1 because of this one. So the 1 is on here. 1 is down here, so we've got a 1 on one of those 2 cells. There's something I missed with this. Just trying to see if any of these were more restricted. But I don't think so. I think these aren't going to interact with these. This is 8. This is like a 3-7 or a 4-6. 3 is looking over. Hmm. 8 in this box. Ah, okay. 8 by Sudoku looks over here, and this 8 looks down. And we've already rolled 8 out of these cells, so this is an 8. Which takes 8 off this line, which might be helpful. And then 8 by Sudoku is down here. Any other basic Sudoku I'm missing? 6 in this row is in one of these 2 cells. 6 is here, then 6 is here. That's fine because of where it would go in row 5. So this cell is actually, it can't be 1, 2, 3, it can be 4, 5, 6. Just to mark that. I don't know if that'll help or not. See where 7 can go. Okay, so. All right. I wonder if it has something to do with. I don't think so. Looking to see if a 1 is on here, we know 1 is here. So then this cell would have to sum to the same as 2 of these other cells. It feels like I'm missing something simpler than that. This is a 4. This would be 4, 6, 1, 6. All right, so maybe we have to think about what the maximum for this is. So the max is 17. If this can be as high as 7 because it can't be 8 or 9, and this could be 4, 6. So this would be 4, 6, 7. But it can't be 17 because this would need to be 8, 9, and it can't be. So this is a max of 7 as well. So actually the maximum sum is 15 as a 7, 8. But I think that's possible in a lot of ways. I think the minimum is even 7. Because this could be like 1, 2, 4, 6, 1. Okay. What else is there? Still not this 10 line, I don't think, because again, we don't know a lot about box 9. About this down here. I haven't thought a lot about this. So this is either 4 cells summing to 10 as one segment, or it's these two. If it's divided, this would have to be 8, 2. Because it couldn't be 4, 6. So then the only way to do that would be 8 and 2. And this would have to be 3, 7 or 4, 6. Is there a reason this can't be 8, 2? It's a little bit of a chain here, but if this is 8, 2, this then becomes 1, 6 to make this work. Because the 2 would be gone, this would be 1, you couldn't use 4, so this would be 1, 6, 7. In 8, 2, we'd have a 7 here. So this couldn't be 1, 9, 2, 8, 3, 7, it would be 4, 6. Doesn't feel right to be looking at that. I also noticed here, trying to ask what happens if this is 6, because it takes 6 out of here would make this a 2, 4, 5 triple. This would be a 6, 8 pair. Actually, this would be 8. These would all be 8. If this is 6. And this would be 6. That would be 6. Okay, well, that feels a little bit too chainy. What I can see is this can't be a 6, because if this is a 6, you can't have a one segment summing to 10, so it would have to be at these two cells. And we already said this can't be 4, 6, so that's not 6. Oh, I see the point. Oh, that's clever. Okay. If this is one segment summing to 10, this is 1, 2, 3, 4. This would have to be the 4, and this would be a 1 or a 2, because there's already a 3 in the box. And so the 3 would be over here, this would be 4, and this would be a 1, 2, 3 triple. If this is 8, this can't be a 4 cell or a 3 cell, so it would be 2 cells with 8, 2. So this is always 1 or 2. That's really cool. So then we've got 1, 2 pair making that 3 and 1. I don't know how far that's going to get me, but it at least got me somewhere after sitting here for a while, making no progress. So that's 8, 2. Okay, this would be 8, 2. If this is a 4, this is a 6, and this has to be a 1, so this is always a 2. I think it's probably obvious, but if I put an 8 here, and this is a 2, just to make this 10 line work. If I put a 4 here, this needs to be a 6, then this would have to be a 7, so we need a 1 here, and this is still a 2. Nice. So we've got, this is a 2 and a 1. And as soon as we get this 1, we know this can't be 4, because that can't be 5. So that's 6, that's 7. And this has to be a 2, 5. That's not 5. That's not 5. Now we're getting somewhere. Okay, I've got this 6, so this is not a 6. I pulled 5 out of here, so these can't be 5. Because remember, these are the same digit. This is 4, 6, and 8. Which gives us, for the row, this gives us a 1, 4, 6, 8 quadruple. So this can't be 4, this can't be 6. So these are 2, 3, 5, and 7. I guess I'll pencil mark that in case we need it. I still don't see restrictions on here. Got this 2, 5. 7. 7 is here. 7 is there. Okay. 7 is here. Oh, okay. So in box 7, where does 7 go? Can't go in here. So it needs to be with the 5. So it's a 5, 7 pair. Taking 7 out of that cell. So 7 is over here for row 3. 5, 7. This needs a 3 up here. 4, 6, 8. So this is 3, 4, 6, 8. That gives us a quadruple in this. So this needs to be 7, 9. Okay. This 4, 6. So this needs to be, oh, cool. Okay. Make sure I did that right. So that's 7, 9. Just because we got this, it's a 5, 7, because if 7 can't go here, and 5 needs to be here with the 7. And this can't be, okay, just double checking my math here. Okay, so 5, 7, this is 3, 4, 6, 8 for the column. That makes a 3, 4, 6, 8 quad for the box, which makes this a 7, 9 pair. The 7, 9 pair looks down, and we need a 4 and a 6 for column 2. The 6 makes this a 4 and a 6 and a 4. Here, making this a 4, and this an 8. Okay, I don't feel too badly about not seeing that at first, but how this was restricted, but that is really cool, and it gave us a pretty nice reward for finding that too, which is always good. Never feels great when you make that kind of a deduction and you get to like eliminate a pencil mark, in my opinion, anyway. So this 10 line is divided this way. Let me use different color. I'll use red down here. Okay, so we already said by the logic we did before, this has to sum to 10. It can't be 2, 8, 3, 7, 1, 9. So this is 4, 6. That makes this an 8. That an 8. So our line here is done. This is an 8. I'm sure that did some other stuff for us. This 4, 6 pair looks like taking 4 out of here. Actually, we probably got a lot. Can't be the 8 that I missed because we just got a ton of digits all at once. This 8 looks up making that a 7 and that a 3. Takes 3 out of these cells, and this is a 7, 3. Okay. The 7 comes out of these, so it's a 2, 5 pair. So we know this triple, 1, 6, 7 triple. That's not a 1, that's not a 7. And that, more importantly, that's a 4. Makes that 6. Taking 6 out of here. This 6 also looked over. That's the other way. I thought that looked strange, but that's why. Don't know this 2, 5 yet on this 4. Make that a 6 and a 4. 6 makes this a 1. Okay, so this is 2, 3, 5. I immediately see there's a 2, 3, 4 triple here already, so that's a 5. Lots of triples in this puzzle, and quadruples, which are kind of come surprising to me, the way they come up. This is 6, 7, 9, but this is not 9 because of Sudoku. 6, 7 pair. This can't be a 4. So this is to complete the row, or the column, 2, 3, 5. It's not 3. That 2, 5 makes this the 3, that the 2, that the 4. That the 3. This is a 6, 7, 9 triple. So what are these? 1, 2, 5. This 2 makes this 1 or a 5. We need a 6 here. We need a 3 here. We need a 2 here. And a 4. Okay, just by Sudoku looking across. Okay, we got 8s, so one of these needs to be an 8. That one's there. We've got a 6, 7, 9 triple here, so this can't be a 6, that's a 3. So if that's not a 3, that's not a 7. Okay, so we've got this triple. This row needs 1, 4, 5. This can either still, I think, be 4, 6, or 1, 9. I think both of those work still. How about this? So this is 5, so this is either 10 or 7. So this sums to 10 or 7. So this can't be a 5. Because to make 10, this would be 6, 4. Actually, this is always just a 6, right? Because this 7 or 10, this will have to go with a 2. So this is just a 6. It's an easier way to see it. 8, 6, 6. Okay, so this is either 1 or 4. It's not a 5. So that's a 5. We need an 8 for this box, and by Sudoku goes up here, just confirming the earlier pencil mark. This is a 2, 3 pair to complete the box. We know the order because of that 3. That's number 2. We have a 1, 4 pair here, so that's not 4. Okay, so we've got this column still needs a 1 and a 4, but this 1 tells us this is 4, this is 1, this is 4, this is 1, this is 4, this is 6, 7, 9, 7, 9. 6 looks to me 7 and 6. Okay. This is 7, so that's what I said before. It could be as low as 7, and it is. So 2, 5. That's not 2. 2 by Sudoku into box 9. Or better, where is 2 in row 8? It's not in any of those cells. Not there, and it's not here by Sudoku. So that's 2. Which means this column needs a 1, 5, 7, 5. This 5 makes this 2, 1. 2. This row needs a 3. This row needs a 7. And this row needs a 5. This doesn't include a solution, but we'll double check the math here. But this sums to 10. This is 7. This is 7. These each sum to 10. That sums to 10. That does. These do. Okay, 7, 7, 7, 9, 9, 9, 8, 8, 8, 9, 9. Yeah, that's everything. I'm satisfied with that. Fun puzzle. Definitely on the trickier side, especially some of these spots here, just kind of mixing in these steps with Sudoku with ruling stuff out based on these combination of 10 lines and region sum lines. But had a lot of fun. Thank you, Isamook, for this puzzle. Thanks everyone else for watching. I hope you enjoyed it too. Leave a comment if you did, and I'll see you again soon. Bye-bye.